Okay, so in today's lecture, we will discuss in brief about the plain sedimentation, right? So in the last lecture, we have discussed about the uh, screening or how or what type of screens we normally use in case of the sewage treatment plant or water treatment plant. That part we have seen in the last lecture. Now today, we're going to discuss about the plain sedimentation. Okay, so sedimentation or settling is a process in which the solid particles or solid and liquid are basically get separated from each other. So that is the main purpose of settling or sedimentation where the settleable particles or settleable solids are actually the time is given to those particles so as to because of the gravity they'll come down at the bottom of the sedimentation tank. So this is the basic purpose of sedimentation. Now, there are two ways by which we do the separation or settling. The first part is where the overflow is taken place, and second is the underflow takes place. So, what are these? We'll see in the later slides. What is overflow and underflow? The basic concept behind settling is the gravitational settling. So because of the gravity, the solid particles which are heavier than water comes down at the bottom of the tank or the channel. Now here we already know that suspended solids having the specific gravity. That means weight of the solids are higher or greater than the water. So those are heavier. So because of that, it actually tends to settle down. So it tries to settle down by the gravity when the turbulence is retarded. We already know that in case of settling, we actually make sure that the water is being steady for a longer time so as to occur the primary settling. The basin or the tank in which the settling occurs is called as the settling tank, and the average time for which the water is being retained in a settling tank is called as the detention period. Detention period is a time where the water is allowed to be steady in the given tank for that time being. So if I say detention time is 2 hours, that means once the tank is completely filled with water, there will not be any inflow or outflow from the tank for the time of 2 hours, for the period of 2 hours. So this is what we call it as detention period. Now sedimentation is normally done by four types, or there are four different ways by which we do the sedimentation. First is plain sedimentation. Then second is sedimentation with coagulant or coagulation. Some chemicals are added to into it. Then next is chemical precipitation, and last is discrete particles. So we'll see one by one. So basically, there are four types of settlings. First is discrete particle settling. So we already know the meaning of discrete. Discrete means the particle behaves individually separate. So each and every particle settles on its own without taking help of anyone, or without being in contact with any of the other particles. So this is what we actually do, or this is what discrete particle settling is. So here you can see that the particles settle individually without any interaction of neighboring particles. So this is the first type. Then second is hindered settling, right? So here basically a suspension is created, or the flock is created. Now what is flock or flocculation means? Some chemicals are added into the water, and what those chemicals does is it actually attracts all the solid particles to it, and it creates a combined mass of different particles along with the chemical. So it creates a bubble where all the particles are attracted to the chemical. And as we know that it will get heavier than water. It will get heavier than water, so it will definitely come down at the bottom of the tank. So this is basically the faster way of doing the settling as compared to the discrete particle settling. Next is a zone settling. In case of zone settling, as hopefully we have seen different types of zones. Uh, I guess in the next slides also we'll be looking at what are the different zones in the sedimentation tank. So zone settling means we are giving a particular space for the particles to settle. This is what, in short, we call it as zone settling. And lastly, compression. So this is basically a step where we compress the fluid in a such a way that the solid particles are getting separated from the water particles. So this is what compression is. In case of the regular water treatment, we are focusing on water treatment only. In case of water treatment, primarily type 1 and type 2, that is discrete particle settling and hindered particle settling. Those are only two types of settling occurs. This zone settling and compression settling usually occurs in case of the wastewater treatment. So if you are treating wastewater, then we'll be looking at the zone settling and compression settling. So this is a typical view, you can say, of different types of settling. So at this particular zone, you can see water will be somewhat clear because the particles are getting settled at the bottom. Particles are getting settled at the bottom. At this particular zone, we'll be looking at the discrete particle settling. The flocculent settling will occur in this zone. The hindered settling will occur at this zone, and the compressed settling will occur at this zone. So as you go down, intensity or amount of particles to be settled or amount of particles which are present in the water are getting higher and higher. At the top, you'll be getting somewhat clear water, but as you go down, you'll be getting the heavier or rather more solid particles. Okay, so this part we are not focusing. This is the major part we are focusing on. So we are focusing on discrete particle settling. So in case of the discrete particle, firstly one should know the size, shape, and gravity of particle, right? So as we know that each and every particle is behaving separately, it is not in contact with any of the other particles. So particle size, shape, and specific gravity will not change because it is not getting in contact with any other particle. So its shape, size, and gravity or weight, you can say, everything will remain as same. Now next is in case of discrete particle settling, the settling velocity will also remains constant. Now if any particle which is suspended in water, it has two forces acting on it. One is the force of gravity. The force of gravity direction of this force will be vertically downward, and buoyant force, right? You already might be knowing this force, which is the property of fluid, or this is also called as force of buoyancy. So this buoyancy force will act vertically upward. So these are the two different forces which are acting on a suspended particle. And if the motion is initiated, now this motion will come when one of this force out of these two, one force will become predominant, or the value of one force, if it is becoming more than other force, then in that particular case we'll be having the motion. Now if the motion is there, then a third force is created due to viscosity. I guess you know viscosity. Viscosity is the property of fluid which resists the motion of the fluid, right? So this is what we call it as friction in the water, which is also called as viscosity. And because of this viscosity, another force is created, which is called as the drag force. So these are the three different forces, you can say, are you can say the three forces acting on a particle which is suspended in water. Now next is how to find out settling velocity. Now just a minute. Can you see the screen? Can you see the screen?
Yes, sir.
Okay. So settling velocity is calculated by formula. You can see the formula g upon 18 into g minus 1 into d square upon v. So here g is the gravitational acceleration that we know. Then capital G. What is the I guess in case of soil mechanics, you might have came across the term G, capital G. So what is capital G? What is capital G? Okay, maybe in your first unit of solid soil mechanics, you might have came across the term G, right? So G is basically a space. G is the specific gravity of the solid. Then d is the diameter of the solid, and as we are assuming that the uh, particles are in a circular or spherical dimension, so we are considering the diameter, and lastly mu, which is called as the kinematic viscosity of fluid. So if I know each and everything, G is already known, specific gravity of let's say particle is known, the diameter of particle is known, and kinematic viscosity of fluid is known. Based on that, we can calculate the V, which is called Vs, which is the settling velocity. Now remember this formula is also called as the Stokes law for finding out the settling velocity. This formula is derived in 1851. Any doubt till now? Any doubt till now?
No, sir.
Now next is different types of settling tanks. So I guess this concept we have seen in the last lecture also. So settling tanks may have the function of intermittent or continuous one. So if this settling velocity, if it is we are providing this settling velocity, then in that case we can have the continuously flowing sedimentation tank. So here the uh, fluid or rather the water will flow in a continuous way with the velocity less than equal to settling velocity, so that particles will settle down. Or also sedimentation tank sometimes may function as intermittent. So intermittent, in this case what we do is the water is allowed to enter into the tank, and once the water gets filled, both inlet and outlet are closed, and water is allowed to retain in the sedimentation tank for the given detention period, right? So particle or rather the water will be there within the tank for let's say 2 or 3 hours without any inflow or outflow. So this is what we call it as the intermittent sedimentation tank. Now here you can see that the settling basins or sedimentation tank can be of long rectangular or circular, right? So these are the two basic you can say dimensions or other shapes of the settling basins. Just a minute. Okay, sorry for the disturbance. Okay. Am I audible?
Yes, sir.
Okay. So, settling basins are of two maybe shapes. One is mostly a long rectangular or circular one. Sometimes the long narrow rectangular tanks with the horizontal flow are also preferred, and circular tanks with the radial flow is also you can say preferred. So these are the different types of settling tank based on its shape. So this is the typical you can say a view of a rectangular channel. So here this type of channel is also called as fill and draw type tank. So here you can see this is the inlet, let's say this is the outlet, and this is the rectangular dimension. So normally what happens is once the water is allowed to enter, so water has reached to this level, then inlet and outlet both are closed. And if the time is given, particular time is given, the sludge will accumulate at the bottom of this tank. So this is a typical view of the rectangular tank. Now I guess this is the horizontal flow sedimentation tank. So here you can see the inflow and outflow. You can see the inflow. This is the inflow and this is the outflow. And here the flow, you can say the horizontal flow is measured here. So water is allowed to enter in this horizontally and it is also going out in the tank horizontally. This is the sludge hopper which is used to remove the sludge, which is used to remove the sludge. And you can see here a slight slope is given to the base of this sedimentation tank. So because of this slope, what is happening is how much amount of sludge which is generated here, right? Through this drive unit or through this, you can say scrappers, through these scrappers, the sludge will accumulate here in this sludge hopper. And if the sludge is accumulated here, we can easily actually remove this sludge from the sedimentation tank. So this is a typical working. You can see here, this is the pump, you can say. Just a minute. Okay, so this is, you can say this is the horizontal flow sedimentation tank. Okay, so if I need to design a sedimentation tank, if I need to design a sedimentation tank, firstly, we have to make sure that we know the inlet of, or rather the how much amount of water we are getting treated. So uh, to design the sedimentation tank, few of the concepts should be known. First is the detention period. As I told you earlier, that detention period is the time given to the water so that the settling will occur within the sedimentation tank. So water is retained or water is detained in the tank for that much time. That is what we call it as detention time. So to know the detention time, firstly, volume of we should know the volume of basin. Volume means we have the L into B into H. You can say volume of basin and the discharge rate. Discharge rate. So if I know volume and if I know the discharge, based on that, this detention period can be calculated as LBH upon Q. So volume upon Q. Right. So from this we can calculate the detention period. For a typical sedimentation tank, the detention period may vary from 4 to 8 hours. 4 to 8 hours. Now, next is flow through period. It is the average time required by a batch to pass through a sedimentation tank. Right? So once the water is inletted into the sedimentation tank, once the sorry, once the treatment or once the detention period has over, then we have to remove that water from the sedimentation tank. So what is the time required so as to, you can say, empty the sedimentation tank is called as the flow through period. And next is displacement efficiency. It is basically the ratio of water flowing through period or flow through period to detention period. So this is the displacement efficiency. It is normally represented in percentage. So if I multiply this by 100, I'll get the displacement efficiency. And next is overflow rate or and surface loading. So surface loading is calculated by the formula Q by A. Now surface loading is the quantity of water which passing per hour per unit horizontal area. Right. So per hour, how much amount of water is passing, how much amount of passing water is passing. And when I say amount of water, we are talking about the volume of water. So how much volume of water is passing through the unit horizontal area is called as the surface loading rate or surface loading. These are the common, you can say, surface loading and detention periods normally used. So here, so for plain sedimentation, the range of, you can say, surface loading, which has a unit, you can say, meter cube per meter square per day. So meter cube of water per meter square of the tank area per day. So this is what surface loading rate is. Its range for plain sedimentation is 0 to 6,000, and typically we take the design value as 15 to 30 meter cube per meter square per day. Then detention period lies from 0.01 to 15 hours, and a typical value which we use is 3 to 4 hours of detention period. In case of plain sedimentation, these are the different particles which are removed. The next is in case of the horizontal flow circular sedimentation tank, the design value is taken as 30 to 40, that is surface loading will be taken as 30 to 40 meter cube per meter square per day, and detention period is given as 2 to 2.5 hours. In case of the vertical flow clarifier, the surface loading is taken as 40 to 50 and detention period is given as 1 to 1.5 hours. Then next is SOR, which is called as surface overflow rate. So this surface overflow rate is calculated as volume of water in liters per hour divided by SLR. So SLR is surface loading rate. So if I know how much amount of water we are processing in hour, and if I know the surface loading rate, then I can calculate the surface area of the tank. Surface area of the tank. Once the surface area is known, we take the length to width ratio as this. So you can assume the length to width ratio between 3:1 to 5:1. Depth of basin is normally taken as 3 to 5 meter, inclusive of all the allowance for sludge storage. So we know that once the sludge gets settled down, only top of this uh, tank will be having water, and the bottom few inches, or you can say few centimeters, will be having the sludge. So including that, the depth of basin is taken as 3 to 5 meter, and normally bottom slope is given as 1%. As I showed you in the figure, bottom slope is taken as 1% for rectangular and 8% for circular. So these are the different zones. I'll tell you. This is a regular tank. Then in this is the inlet zone. Inlet zone means the water enters firstly into this zone. Then this is the settling zone where the water is allowed to stand or water is allowed to be still in this zone. This is the sludge zone. which is at the bottom of the tank, due to which due to which the sludge will accumulate at this zone only, and this is the outlet tank. Once the settling is done, we take the water out, which is called as the outlet zone. So here you can see that inlet zone is a region in which flow is uniformly distributed. So the flow is entered into the inlet zone. Settling occurs in the settling zone. Then clarified effluent, that means the water without much of the sludge is collected in the outlet zone, and it gets discharged over this weir. And lastly, sludge zone is a collection of sludge below the settling zone. So here below the settling zone we have the sludge zone. Okay, so I guess we have seen this example. Okay, do one thing. Take a screenshot of this. Take a screenshot of this, and what you need to do is, if have you taken the screenshot? Have you
Yes,
taken?
sir.
Okay. Okay. So if what you need to do is, you have to do the design steps. If the water need to be treated is 2.8 million liters, and if the detention time is 4 hours. Right. I'll repeat. If we have to treat the 2.8 million liters, and if the detention period is 4 hours, then what I want is, what are the length and width of this sedimentation tank. So maybe as a part of homework, you have to solve the example and you have to tell me the answer in the next lecture. Okay, is that fine?
Yes, sir.
Okay, so solve this as a part of homework. Solve this as a part of homework, and we'll discuss these values in the next lecture. And in the next lecture, we'll be talking about the different devices and the different other types of, you can see, sedimentation times. So that part we're going to discuss in the next lecture. Okay.